Hello everyone, I am Jack and I'm back and I'm on a different phone, so I may screw this up a little bit. It's in a case and the lid on the case gets in the way, but I'll continue on. All right, so I have the Mach 3 up, computer booted with Mach 3 display up, and I am going to go over here and click on File, load G code, and go down here to Roadrunner, which comes with Mach 3, and click open. All right, so now it's loaded. I've already hit the reset. If this is flashing, you will have to hit that. If something is wrong, it will let you know. So what I'm going to do is cycle start. If anyone knows a faster way to do this, this is just what I've been doing. So I click on it. And if you look, now the numbers are scrolling, the indicator's going down, and if you look over here, it thinks it's got a tool moving over there. If we come over here to the end of the RS-232 cable with the tester plugged in, you can see the various lights flash. To me, that indicates that stuff should be moving if it was hooked up to the control box. It's not. Reason it's not is because with it hooked up to the control box yesterday, nothing happened. So now I've got to figure out why nothing happened. So luckily, a member in the DIY CNC group called me and went through a lot, the basics of all of this. This is the Hitachi inverter. It's a project for another day. It makes the spindle go around, but since I can't even get the motors to move, stepper motors to move, doesn't matter whether the spindle moves or not. All right, so he said that he had seen there's no power to it. Let me power it up. Oh, by the way, I found out by stretching all the cables as far as they would go, I could just get this in the office. Both the office and the shop are air conditioned, but the shop is huge. The office is small. Shop is 1,000 square feet with a very tall roof, and the shop has a low ceiling and is only 400 square feet. So I can run a separate air conditioner on it. So that's what I'm going to do. Right now it is 5 o'clock. It's really not, and it's Texas. It's right at 100 degrees. It's not worth turning on the air conditioner, cool off this office because I'm getting ready to leave. But I wanted to stop and do the testing that he had suggested so that I can make progress. All right, so I will turn on the power. You hear the thing come on. All right. He was saying something about either the yellow light or the red light here meaning something. If you look, the red is the emergency stop, and could be that that light has to go off before anything happens here. I do not know, but the other suggestion is since the drivers have the lights on, X, Y, second Y isn't even hooked up here. I don't even know what wires would go there, but at some point I've got to figure that out. Then it's got these connectors that are disconnected, but there are also two controllers. The A and B controllers are missing. So here we go. There we go. That's not connected to anything. So these two look identical. My guess would be they go to the A and B. Since this is red housed thing, like all of these, there's red. See, it's comes from a red bundle. Each of these, the red bundle comes off of one of these. So I don't understand why this one's different than the others. I would expect the exact same setup here, wires like that loose, and then a connector like that somewhere. But it's not here. So again, worry about A and B later. If I can get X, Y, and Z, actually X, Y, Y probably, and Z going, I would be happy. So his suggestion was, start with 1. So I am going to start with the X. The problem is there are 6 sets of wires. 1, 2, 3, 4, 5, 6. Sure enough, 6 sets of wires going out of this box into a bundle that is very long, probably 10 feet or something like that. And then it comes out the other end. So the challenge now is to figure out which one of these many wire bundles is X. So what I'm going to do, I'm going to shut this off, and then I am going to use my multimeter, which I just got a battery for, so it works. And I am going to test and see, I'm going to pick a wire. Let's say the black wire, doesn't really matter which one, but pick one of these wires on the X. Go to the end of each of these, touch it to, let's say I pick the black wire, and one of these is going to show continuity. So that I will know is the wires coming out. For the X, I will label it so that I know. I could do it for all the others too, I may or may not, but right now the goal is just to get the X going. Once I do that, he explained that the wires on the stepper motors, see, this one doesn't have any power because I can turn it freely. This one does have power because I cannot turn it no matter how much I put. So that's getting some kind of power. I just don't know where, and I don't know, like I said, I've never seen it move as it's running through the program, so it must not be hooked up correctly. So what he told me is each of these wires, there's 4 wires coming out, there are 2 pairs. So what you can do is you can touch the pairs to each other with it disconnected, sitting on the bench, and if you got the right pair, this won't turn freely anymore. So once I get one pair to where it doesn't turn freely, then the other 2 are obviously, well, the other pair. So what I'm going to do is, let's pick this stepper motor just randomly, and I use these wire taps because they're really easy to connect and disconnect. Ouch, that has voltage. I think I'm gonna turn this off. All right, got a loose wire there. Oh, and of course that is to, that's to the motor, the spindle. So yeah, that's gonna have voltage, not only voltage, but significant voltage. So I need to fix that so it doesn't have power, or at least fix that so those wires aren't exposed. Real easy, I'll just put the connectors. I disconnected the connectors and they're on the other side of this. I'll switch them so that those are insulated. Okay, so safety last is my motto. Okay, so each of these I'm going to disconnect. Sorry, I'm gonna have to set my phone down while I do this. So I want to disconnect the motor, ideally. Not that it matters, it just has to be disconnected. There's one. And there's 2. And 3. Whoops, that disconnected. There we go. And last one, 4. Okay. This stepper motor. Come over here. It turns, where we go? There we go. It turns freely. So I'm going to randomly pick a pair. Oh, these 2 seem to be paired together. I'm just twisting the wires together. Off camera. There we go. Oh, that didn't work. All right, so I twisted the, there we go, red and green together. And I come over to this, and it still turns freely. Must not be a pair. So disconnect. And by the way I wired this previously was, this is what I used as an example. There are a couple others. If you look at this, the red wire here looks like it goes to the green wire out of the harness. And the green wire looks like it goes to the blue wire out of the harness. The green wire, no, blue wire looks like it goes to, I think this was white, if I remember right. Yeah, I can barely see the white right there. Went to the white out of the harness, and then the black wire went to the red out of the harness. Now, the ones, only some of them had a little length of wire after the splice. So I used that as a guide, and I think 2 of them had that, and they were the same. So I just assumed all of them were the same. Well, then yesterday I ran into one that was different. So that's not necessarily the same on all of them. Why they wouldn't have done the same, I don't know. All right, so we're going to pick the red as the base, the red out of the stepper motor, which turns to green. And we'll pick the blue out of the stepper motor. Okay, off camera, I'm going to twist those 2 together. Holy smokes, that's it. So now I can turn it, but you can hear. Okay, so those are pairs. All right, and then just to verify the other 2, I can turn it freely. You can't see it. Let me show you. Okay, I can turn it freely without the wires. I'm going to twist the 2 together. And sure enough, resistance. So now I know for future reference, the black and the green are pairs, and the blue and the red are pairs. Okay, so transfer this to here, and we see that there's an A, 2 A's, and 2 B's. The A is red and black, and the B is blue and white. Now that's from the harness, which is completely different than out of the motor. So if we look at this, A and B is red and black. So if we look, the red, now that's weird, because the blue, oh, there we are. Sure enough, if I look at that end, the red and the black are paired together, and the green and the white are paired together. Green and white. There's blue and white. Oh, I guess that is blue. My bad. Okay, yep, sure enough, blue and white. Okay, so that matches what's there. Now I just have to figure out this harness. Which one of these is the X? So rather than bore you while I go off and use my multimeter and test, that's what I'm going to do. And then I'll come back to you after I've figured that out and continue on. Like, subscribe, hit the alert, hit the thanks if you want to donate. And if you don't like what I'm doing, you don't know Jack. Bye.